Hello, hi. Um, this is homework 3 from the team of Jeff Shamp and Gracie Han. Jeff Shamp did a majority of the work, even that I'm in the team with him. So we were told for this week to choose a graph database and then do some analysis on that. The database we chose is the Reddit discussion from the Stanford Large Network Database Collection. So first, Jeff imported a library and then read the JSON files into the network. So the first trial for the graph is to look at the entire data set, the first 10,000 nodes of the data set as a whole. And then, but it takes just way too much time and have met too much difficulty in the network connection. So therefore, this approach was abandoned. But here are the codes. First, the graph is generated, and second, the nodes were added, and then the edges were looked at, and then diameters were looked at. So here's the entire chunk of codes which didn't run. So instead, in order for this data to run, a built-in graph generator from network X, which is a DGM graph, Dorokaskos, Goskov, Mendes were looked at. So it was chosen as this default, and here's the graph, how it look. So next, as the professor has asked, looking at some analysis. So the first analysis, the matrix. The diameter of this network has 5. It's amazing that even despite the large data set, it has a small diameter. And then the matrix he's looked at is the paths. There are two paths that he looked at. One is the shortest distance path. The other is the Kuff's path. By mathematics, they are the same. And in this situation, because the shortest distance is unweighted here, so running from node 10 to 100, we can see that these two paths have the same result, which confirms the assumption. And then the length is actually 3. Next, the degrees are looked at. So the degree values is like this. There are 3 of 32 and 3 of 16, and 9 of these 8, and then 27 of these 4s, and then 81 of these 2s. They actually follow a second function. It's very interesting. So that the first few nodes serve as hubs, and then the next follows 2 times n functions. So the next is the degrees. The degrees values is such, which is the Karate Club degrees. So finally, the DFS, the algorithm, are looked at. So this DFS is the depth first server algorithm. So its default is shown here, and then the second, the BFS, which is the second algorithm. It's a breadth first search algorithm with the tree shown here. So these are the first look at those crude look at of those networks, and then the next to-do list is to fine-tune these graphs, including edges, trees, predecessors, successors, and etc. So here concludes the homework 3. Thank you.